Experiment 2. Aim to find resistance of a given wire using meter bridge and hence determine the resistivity specific resistance of its material. Apparatus: a meter bridge, battery eliminator or leg launch cell, a galvanometer, a resistant box, a jockey, a one-way key, a given wire of unknown resistance, a screw gauge, a meter scale, connecting wires and a piece of sandpaper. Theory: A. Meter bridge. Slide wire bridge or meter bridge is the practical form of Wheatstone bridge. It can be used to measure an unknown resistance or to compare the values of two unknown resistances or to verify the laws of combination of resistance. Usually, R1 and R2 are called ratio arms of fixed resistance. R3 is an adjustable or variable resistance of known value. R4 is replaced by an unknown resistance X as shown in figure 2.1 and balance point is obtained at D on the meter bridge wire. Since the bridge uses 1 meter long wire, it is called meter bridge. Since the jockey is made to slide over the wire, it is called a slide wire bridge. Figure 2.1 Wheatstone's bridge network. B1. For unknown resistance, let AD equal to L centimeter, then DC equal to 100 minus L centimeter. As the meter bridge wire AC has uniform material density and area of cross section, its resistance is proportional to its length. Hence, AB and BC are the ratio arms and their resistance correspond to resistance R1 and R2 respectively. For a balanced Wheatstone bridge, when galvanometer shows 0 reading, then R1 by R2 equal to R3 by R4. 1. But from figure 2.2, AB equal to R1 equal to R equal to resistance from resistance box, BC equal to X equal to unknown resistance R2, AD equal to L equal to balancing length on meter bridge wire equal to R3, DC equal to 100 minus L equal to R4, R by X equal to L by 100 minus L or X equal to 100 minus L R by L, working formula for unknown resistance. 2. For specific resistance, as resistance of a conductor depends upon its length L and area of cross section A, example, X proportional to L, A, X proportional to 1 by A, B, combining A and B, X proportional to L by A, X equal to rho L by A, where rho is the specific resistance C, or rho equal to XA by L for a wire of length L, radius of the wire equal to R equal to D by 2, where D equal to diameter of given wire, A equal to pi R square equal to pi D square by 4 D. Hence, rho equal to X pi D square by 4L using C and D. Circuit diagram. Formula used. The unknown resistance X is given by X equal to 100 minus L by L R, where R is known resistance placed in the left gap and unknown resistance X in the right gap of meter bridge. I. Centimeter is the length of meter bridge wire between 0 mark and the balance point. The specific resistance rho of the material of the given wire is given by rho equal to X pi d square by 4L, where L is the length and D is the diameter of the given wire. Procedure. For unknown resistance, draw a circuit diagram as shown in figure 2.2 and arrange the various components of the apparatus as shown in the diagram. Clean the connecting wires using sandpaper. Connect the resistance wire whose resistance is to be determined in the right gap between C and B. Connect resistance box of low range in the left hand gap between A and B. Make all the other connections as shown in the circuit diagram. Take out some resistance from the resistance box. Insert plug in the one-way key K. Touch the jockey gently first at left end and then at right end of the bridge wire. Note the deflections in the galvanometer. If the galvanometer shows deflections in opposite directions, the connections are correct. If it deflects in one side only, then there is some fault in the circuit. Slide the jockey gently along the wire from left to right till a point D is reached, where the deflection in the galvanometer becomes 0. The point D where the jockey is touching the wire is called balance or null point. Choose an appropriate value of R from the resistance box such that there is 0 deflection in the galvanometer and corresponding balance point D lies between 35 cm and 65 cm marked. Note position of point D to know length AD equal to L. Take at least 5 sets of observations in the same way by changing the value of R in steps and record your observations as given in table 2.1. For specific resistance, cut the resistance wire at the points where it leaves the terminals, stretch it and measure its length by using a meter scale. Measure the diameter of the wire at least at 4 places in 2 mutually perpendicular directions at each place with the help of screw gauge. Record your observations as given in table 2.2. Observations and calculations. Record all the observations in the following table and calculate the values. Calculations. Calculation for specific resistance. Result.
Precautions.
The ends of the connecting wires should be cleaned before making connections. The connections should be neat, clean and tight. All the plugs in the resistance box should be kept tight. The jockey should be moved gently over the bridge wire and it should not be rubbed against the wire. The plug in the one-way key K should be inserted only while taking the observations. Null point or balance point should be brought between 35 cm and 65 cm. At one place, the diameter of the wire should be measured in 2 mutually perpendicular directions. There should be no kinks or loops in wire. Sources of error. The instrument screws may be loose. The plugs in the resistance box may not be tight. The wire may not have uniform thickness. The screw gauge may have faults like backlash error or wrong pitch. Inaccuracy in the measurement of the length of given wire.